basic theorem and equality of two sets. See here, we are going to prove this condition under the advanced level. Here, this theorem states that if X is a subset, a set X is subset to the another set, that is Y, and the set Y is a subset to the first set, that is X, then two sets X and Y are said to be equal. Then now here the theorem states that if set X is a subset to the set Y and set Y is a subset to the set X, then we have to prove X equals to Y. Then show that X equals to Y. Say here X equals to Y, it is to be proved. Or in other words, if X is a subset to Y and Y is subset to X, then show that or prove X equals to Y. Then now proof starts now. So in our proof, say here as per the condition which is given to us, as per the condition given, X is the first set, X is a subset to the second one, and the second one, that is Y, is a subset to X. And here to be proved is of, required to be proved is of X equals to Y. Then now in our proof, we are going to assume. So here in our proof, we are going to assume that X is not equals to Y, but here we have to prove that X equals to Y, but I am going to assume, our assumption is of X not equal to Y. Let us assume that X is not equal to Y. If X and Y are not equal, that the sets X and Y are not equal, then automatically the sets X and Y do not contain exactly the same elements. So here, since the sets X and as well as Y are not equal according to our assumption. So here are not equal, hence they do not contain or they do not consist the same elements. So here our assumption is X is not equals to Y, set X is not equals to set Y, therefore they do not contain the same elements. Then now here I am going to assume one element, that is P. So in case number 1, so I am going to consider the case number 1. In our case number 1, I want to assume. So here let one element P is belonging to the first set. So here, since X and Y are not equal, if X is P is present, an element P is present in the set X, then now need not to present in the set Y, because here they are of not equal. So here the elements won't be same. So here already we have mentioned that. So here they do not consist the same elements when we assume. So here we are assuming, say let an element P is belonging to the set X, that is the first set. Then now here, and the same element, that is P, won't be in the set Y, that is P does not belongs to Y. And whereas here case number 2, say in case number 2, I am going to assume, so here let another element, that is Q, is belonging to Y. Since X and Y are not equal, so we can add the statement here, since, so set X is not equals to set Y. So therefore P is present in X, but P is not present in Y, because X and Y are not equal, they do not contain the same elements. Then now here in the similar manner in the second case, I am going to assume one element, that is Q, which belongs to Y, and this element Q, so element Q does not belongs to this X, because here X and Y are not equal, so they do not contain the same elements. When Q is present in Y, it need not to be in the X. So here the reason is the same. So here X and Y are not equal, sets X and Y are not equal. When Q is present in Y, according to our assumption, it need not to be in the X. Then now, but in case number 1, so here we have assumed, in case number 1 we have assumed P is an element which belongs to X, but in the first case X is a subset to Y. So here it is given that X is a subset to Y and Y is a subset to X. There are of two cases here. So I am going to use this condition now. So here in the first case, but X is a subset to Y, then that implies, but P is belonging to X, that implies when P belongs to X, then certainly, so here P also must belongs to Y. So here the reason is because X is a subset of Y. So here when P is an element which belongs to X, then that also must present in Y, because X is a subset of Y. What are the elements which are present in X? Those are also the elements of Y. Therefore it also belongs to Y. But here we assume P is not equals to Y. So P is not belonging to Y. P is not present in Y. But here I got P is belonging to Y, which is a contradiction. So here our assumption is wrong then. So here P, so here X equals to Y, say X not equals to Y is a wrong condition which we have assumed. So now let us see in the second case also. So here but as per our assumption, P is not belonging to Y, but here we got, say P is belonging to Y in this case. So here therefore it leads to a contradiction. Hence, our assumption is wrong. That is, X not equals to Y is wrong. Then X equals to Y is the correct one. So similarly, let us see the case number 2. So in our case number 2, so here we have assumed one element, that is Q belongs to y, but as per the condition, but here we know that y is a subset of x. So y is a subset of x, so it is already given. Then now when, so that implies, so here q is an element which is belonging to y. When q belongs to y, then certainly, so here that implies q also must belongs to this x. So here, since the reason is, so here y is a subset to this x, since y is a subset of x, the elements which are present in the y are also the elements of x. So here q is present in y, therefore q also must present in x, since y is a subset of x. Then now here, but according to our assumption, so here we assume that q does not belongs to x, only q is belonging to y, according to our assumption that q does not belongs to x. So here but as per our assumption, q so does not belongs to x, but here we got q belongs to x. So here hence it leads to a contradiction. So from this it is clear that in both the cases, so here it leads to the contradiction. Our assumption, whatever we assume, that is x not equals to y, is wrong. So here x equals to y must be the correct one. Then now here hence our assumption is wrong, that is x not equals to y, then x equals to y is the correct one. So from both the cases, it is clear that x not equals to y is the wrong assumption. Hence x must be equals to y.